And I think in summary, one thing we started with, and also to open up our understanding to, is around statistical method. And we were made to understand that we have two type of classes of statistics. We have the descriptive statistics and we have the inferential statistics. And we also mentioned that descriptive statistics help us to describe our data set, but we do not generalize or make an inference around our descriptive statistic. And oftentimes when we are running a descriptive statistics, our interest lies in using statistics such as frequency analysis, central measure of tendency, and the mean, the mode, the averages, squeenesses, and all of that. Then we have the inference. So the inference statistics are statistics whereby we can draw a conclusion or we can draw an inference about a sample population. So a sample population is when we take a fraction or a proportion of a total population about which an inference can be drawn about the total population. And we also mentioned that some of the criteria that is very key for us in choosing our statistical method has to do with class of measurement, all right? We also mentioned that we have 4 classes of measurement. We have the scale, we have the interval, we have the nominal, and we have the ordinal. And we try to explain the importance of all of these in also in determining the kind of statistical test that we need to use. Then we also mention different type of variables. We have the continuous variables, we have the discrete variables, we have the dependent variables, and we have the independent variables. So we also explain the importance of having this understanding around variables on how it actually helps us in determining and the type of statistical analysis that we also need to run. Now, under the inferential statistic, we also have 2 branched out. We have what we call the parametric test and not the parametric test. Now, before saying that, so generally in research, our interest always lies in 3 aspects of research. Number 1 is when our interest lies in describing our sample population, or probably when our interest lies in finding association or relationship between variables, or when our interest lies in finding differences between or among variables, as it were. So in respective of the research question you are going to develop, in respective of the research hypothesis, as it were, that you are going to formulate, your interest is going to lie in these 3 research questions, in describing your research, that descriptive, or your or finding differences between finding differences between or among variables, or finding the relationship or association between variables. So in terms of inferential statistics, like I mentioned, it branches out into 2 parts. We have the parametric test and not parametric test. Now, one of the key assumption, or one of the key ways in determining if your data set follows, if your data set is appropriate for a parametric test or not parametric test, is by conducting what we call normality test. All right, normality test. So normality test is a way of testing if your data set follows a normal distribution. All right. So when your data set does not follow a normal distribution, then you now conduct an appropriate alternative of a parameter. If we want to, like I said, if you want to run a descriptive statistic, like I said, then you might run some frequency analysis, some measure of central tendency, some measure of deviations, and all of that. But for example, if you need to run a relationship or association, now when your data set scale of measurement, for example, is nominal, that can also be called categorical, then your interest lies in running a chi-square, all right? Because it's a nominal variable or a categorical variable. So for example, you might want to run relationship between sex and education. So the option for sex is male and female, while the option for education, for example, is primary, secondary, and tertiary. So when you're going to run a chi-square for this, it's going to be a 2x3 table, because you have 2 levels for sex, gender, then you have the 3 levels for education, so which make it a standard example for a cross tabulation. Now, you can also use correlation to find association between 2 variables. But in this instance, you are going to use a continuous variable or a ordinal variable. For example, height, weight, salary. They are examples of continuous variable or ordinal variables. So in that sense, you can use a continuous variables, for example, in finding an association between variables. Now, let me go quickly to, yeah, sorry, yeah, I don't really have anything to share. I'm just trying to give us a recap of some things that we've done. But again, let me quickly share this even as we proceed in the class. All right, thank you very much. So like I said, normality test is very important for us to be able to tell if our data follows a normal distribution or not. Because for example, now, if you want to run association, difference between variables, and you want to use one-way analysis of variance, or you want to use multivariate analysis of variance, and you test, discover that your data set does not follow a normal distribution, the close alternative, which is a non-parametric test that can be used, is what we call this Kruskal-Wallis test. Are we together now? It's what we call the Kruskal-Wallis test. So which implies that before you choose an appropriate statistical test, either it is parametric or not parametric, you need to be sure that your data set actually follows a normality distribution. Hence, the need to conduct a normality test. Now, from what you can see on the screen, now testing for normality in STATA can be done, using 2 ways. It's either you use a graphical method or you use a numerical method. I'm not going to dwell so much on these because I'm just trying to give a recap. Now, when you need to use a graphical method, that is when your interest might lie in something like a stem and leaf plot, scatter plot, box plot, histogram, probability test plot, which is also known as PPP test. Then we can also use what the QQ plot. So all of these examples that I've mentioned, they are graphical ways of testing if our data set follows a normal distribution or not. Now, the other numerical method of testing for normal distribution is what we call the Skyrov-Wiki test, or the Shapiro-Frankel test. And also you can also use the squeeness and the kurtosis test. And all of these tests can actually be used in checking for normality. Now, this is an example of an histogram. An histogram can be used to visualize only one variable. All right. So when you want to tell if a data follows a normal distribution when you're using an histogram, now there should be a bell curve, just like what you can see at the first left histogram. So there should be a left curve. All right. Okay, distribution that follows the frequency of occurrence of the data. Now you can see that the bell curve falls as the highest frequency, the one at the middle. Why this other point follows a normal distribution? I don't want to dwell on this because of what we need to do. So this, for example, now is an example of a distribution that follows normal. If you draw the bell across, you can see that it falls at the middle. So when you have this, for example, you have to use a parametric test. This is an example. This is a severe skew. In this case, we have to use a non-parametric test. Why? Because the most extreme histogram interval has the highest frequency. Now, this is different from this because the most extreme interval does not have the highest frequency when you compare to this. So this is several skew. In this case, we use a non-parametric. But in this case, it is moderate squid. We use a parametric test. Why? Because in a moderate squid, the most extreme histogram interval does not have the highest frequency. All right. So this, for example, also is a normal distribution. Now, if you look at this is a normal plus an outlier. Now you can see this very fault at this point, it follows a normal distribution, but it has an outlier at this point. So in this sense, we do not use a parametric test, but we use a non-parametric test. All right. This is another graphical method called the box plot that can be used to visualize multiple variables. Again, I'm not going to dwell into that. This is another one, quickie plot. It can also be used. We can share all of this at the end of the day. Then this is another one called the Lilliefors test. All right. This is also used to test for normality test, and we can see the interpretation in terms of the decision rule. If the p-value of the Lilliefors test is larger than 0.05, the alpha level, we assume that it follows a normal distribution. If otherwise, then it does not follow a normal distribution. So this is another test also using the numerical method in testing all of this. Now, the question is, which approach is best to use? Now, for a quick and visual identification of a normal distribution, the best plot to use is a QQ plot. If you have one variable to look at, and a block spot, if you have multiple variables to look at, then in terms of the statistical test that can be used to test your hypothesis, then the Shapiro-Wilk test is more appropriate in testing for normality. All right. So then we have some examples using our data set and then all of that. Okay. So this is not parametric test. Then you can see the parametric alternative. All right. For all of that, one sample t test, you use the one sample z test. We have the one sample Wisconsin sign rank test. Then we can see the alternative. We have the Friedman test. The alternative is a two-way analysis of variance. We have the Kruskal-Wallis test in case you want to use one-way analysis of variance and all of that. So this test, you can determine which to use. Is it not parametric test or a parametric test when your data set does not follow a normal distribution, all right? So when your data set does not follow a normal distribution, then you use the non-parametric test. I think this is clear. So on this note, I'm going to pause. Then we'll do what we have for today. I'm going to take question. If there is none, then I'll proceed to today's class. So what I've been able to do is just to bring us to a quick, or probably to refresh our memories for what we've done in the past. And if you don't have this slide, which I think you should, we can actually share this as well. So I can take quick questions, quick clarification before we proceed in what we have for today. Over to the class, please. Any questions, clarifications, addition, or what have you? Thank you. Questions? Okay. If there's no any question, then I think I can proceed. No question? Please confirm no question, then I can proceed. Okay. Seems no question, seems everybody is good. Now, this is the STATA environment, and I believe that everybody is familiar with the STATA environment. Of course, like I said, we have, I don't know if you can see my cursor, and this is where we have the title bar, where you can see STATA. Then after that, we have what we call the menu bar. All right, for each of this menu, there's a pull down menu, that takes us to a dialog box, depending on the menu of interest. Then after which we have the formatting bar or the standard tools bar, as the case may be, where we have open, save, print, and what have you. Then we also have 1, 2, 3, 4, 5, 6. We have about 6 windows in STATA. I mean, I've said all of this. I'm just trying to refresh our memory. We have what we call the review window, and that is where you can see my cursor at the left-hand side. Then we have the command window. That is when you can see the middle down, all right? The middle down where you can see command. Then we also have the result window. This is at this point. They can see status, you can see single users STATA perpetual license. Then you can also see the variable window by the top right-hand side. Then you can also see the property window, all right? So we have understanding of this from day one, but I'm just trying to refresh our memory. Now, to interact with STATA, there are 3 methods of interacting with STATA. Number 1 is by interacting with STATA with the use of the command line. That is the command window when you put in your command, number 1. The number 2 ways of interacting with STATA is the use of what we call do file, all right? Do file is like a file where you save an executable commands, all right? So executable command. Or thirdly, you can also interact with STATA using the menu dialog box. Are we together now? So there are 3 methods of interacting with STATA. Number 1 is the use of the command window. That's the command line when you can easily type in your command and what have you. The secondly is the use of the do file. Okay, we've mentioned this in one of our classes. Do file is where you save an executable files, okay, that you can run for your analysis. Thirdly, is the use of menu dialog box, okay? That is when you can go through the graphics menu. You can go to the status menu, all right? So if you don't want to go through the menu dialog box, you can simply use the command line, all right? If you don't want to go through the command line or the menu dialog box, then you can easily go through the do file. That is if you have some command line that you have saved already. Okay, let's proceed from here. Then I also mentioned to us that when we need to start our STATA, the first thing we need to do is to go to file. Okay, from file, you need to begin a new log. All right, you need to begin a new log, and by the time you are done with your analysis, you need to close your log. One important thing about log is that all of your code line and output is being saved in that log. Are we together now? There are instances in MPH classes, even in PhD classes, or even in some interview where people have been asked to share their log. All right. So your log shows the step-by-step, how you imported your data into STATA environment, how you run your code, how your data cleaning and data manipulation and data engineering was done, how your analysis was done, and the result and all of that is saved in your log. Okay, are we together now? So your log is by going through menu. From menu, you click on log, then you click on begin. When you click on begin, then you have to save this with the name test 2022. Then you change the save type to log. All right. So you change it from formatted log, which is the default, to log. All right. Then you select your what have you, where you want to save. So then that is that. Then we save that. That is that. Okay. So the next thing in STATA, when you have successfully begin a log, is to import your data set, or probably is to ingest your data set. And I said to us in one of our classes that there are 2 ways, possible 2 ways of okay, let me say there are 3 ways of injecting data into STATA environment. Number 1 is when you have an already saved STATA file. Are we together now? So number 1 is when you have an already saved an already saved STATA file, you can actually open it into the STATA environment. That is number one. Number two is by importing files into STATA. The file could be in SAS format, it could be in CSV format, it could be in Excel format, that's spreadsheet, or whatever format that is compatible with STATA. Then the third method of injecting data into STATA is the use of the browse edit. All right, browse edit. So this is the browse edit here. So the browse, the editor browse is for you to browse or to view your data set, but you cannot make an edit. While the first one here that has something like a pencil icon is data editor edit. So in data editor edit, you can actually manually type in your data set just the same way you type in your data set in a spreadsheet or Excel environment. Are we together now? So let's know that there are three ways of injecting data into STATA environment. Number one, number two is by importing files that are compatible with STATA, such as SAS, CSV, spreadsheets, and what have you. Then the third method of also injecting data into STATA is by the use of what we call the data editor edit. All right. So I'm not going to dwell on all of these because this is something that we've done in the past. So there's a sample data set that was shared with us in one of our classes, and I'm going to bring that in. So I'm going to go to File. I'm going to come to Import. Now, because the data set I'm bringing in is actually an Excel spreadsheet, then I'm going to select the spreadsheet. Now, note that these are other files that are compatible with STATA that you can import. We have the spreadsheet, we have the CSV, we have the fixed files, we have the SAS, we have the Federal Reserve economic data, we have the ODBS data source, and what have you. So these are other files that are compatible that we can import into STATA. So the first one I'm bringing an Excel. So there's going to be an import Excel dialog box that will pop up. So the next thing we need to do is to click on browse for us to locate where our file is saved so that we can import it into this data environment. So what I have is sample data sets. Okay, this says this is in spreadsheet. Then I select. Now you can see that the preview is loading. Now let me say this to you. When you have your data set saved in CSV, it's going to be imported as a very clearly. When you are importing a file that is saved in CSV, automatically the first variable is going to be imported as a variable name. But when you are importing a file that's an Excel spreadsheet, then you need to manually check this that says import file as first row. Then we click, then you can now see automatically the first row has become the variable name. If you uncheck, it comes back. But when you check, the first row becomes the. Now you can see these are the command line at the command window. That's the review window. Then we can see the variable window. These are all the list of variables that was imported into STATA. So when you click on each of these variables, then you can see their properties in the property windows below the variable window. You can see this is weight. You can see the properties. This is age. This is age cut, and then what have you. And I said to us in our class that one of the things that you do when you import your data data into STATA is to inspect your data set, all right? I also describe many ways by which you can inspect our data set. I'm not going to go into that detail. And of course, we also have a PowerPoint presentation in all of this. So one of the ways that we can inspect our data set is by using the zoom. Now I'm using command method all your data. So zoom is also the same thing as summarize. Summarize in British spelling. Just to see the frequency and what have you. All right, you can tab. So see that you use TAB or TA. All right, some of the things that we've learned in the past. Okay, let me move on here. One of the things we also learned is recording and labeling, all right? For example, we can see gender. Gender comes female. Can see education. Education comes in as 1, 2, 3, and we need to code them in order for us to understand what it implies. We call the variable name, all right? Then we say 1, quotes, close, then this goes. So this is defining it. Now we now label, it becomes label values. Now I'm interacting with state values. Gender equals gender. All right. Then we see what it becomes. All right. I'm sure you can see the difference. It comes in as make 1 to be primary, 2 to be secondary, then go the same route, label, define. We're calling the variable primary. Okay, 2 becomes 3 becomes tertiary. Okay, then again we label the values, then education, education. Enter, then we can now tab education. We also mentioned that when we design questionnaires, we have the close-ended and the open-ended, all right? So when we have the open-ended is when I say, what is your age? And I have questionnaire is when I say, what is your age? and the option is 10 to 24. So these are examples of continuous. Our survey data or our feed data or our program data comes in continuous, and we might need to categorize. So one of the things we also did in one of our classes is to recode. For example, age here. If I tabulate age, we can see that age here is a continuous variable. So let me also say this to us, that the command line is actually case sensitive, all right? So you will note all of our code line at this point. So this age now is continuous, and we want to recategorize this. If you still remember, then we start by recode, then we bring in the variable, all right? We want to record age, and that is age. So the lowest number starts from 14, all right? So I can do 14 equals 1, then 20 to 24 equals 2, 25 to 29 equals 3, then 30 to 34 equals 4, then 35 to 39 equals 5, sorry, 35 to 39 equals 5, then 40 to 44 equals and 45 to 49 equals 7. So when that is done, then we need to generate a new variable. Are we together now? So we are recording age into something else, and that is why we are generating a new variable. So it's either we generate, then we put a comma because we are giving an additional command, all right? So it's either you use gen, EGN, or you write in full, generate. So the new variable we are generating is age, probably, let's say, record, all right? So that is the new age that we are generating. Then we tap, then we press enter. Now you can see that the total observation from this table you can see up here is 449. Now, if you look at the result, 499 differences between age and record, which means that we are good, all right? So now that we have recorded age, the next thing we need to do is to label, define the new generated variable. Are we together now? If you look at the variable properties here, you can now see here that a new variable has been generated, which is called age record, all right? You look at the variable properties. I'm sure you're looking at the screen. The variable window, you can see that a new variable, age record, from this code line has been generated. So the next thing we need to do is that we need to define the new, we need to define a variable that we can link to the new variable. So we say label, define, similar to what we've done before. We can say age record 1 because we need to link it up. Then we say 1 is 14 to 19. We close that. 2 is 20 to 24. 3 is 25 to 29. Then 4, that is 30 to 34. Then 5 is 35 to 39. 6 is 40 to 44. Then 7 is 45 to 49. All right. So that is what we're able to do. Then we tabulate. Now note that at times when you are running your command line, you might get errors. So when you get errors, you will see the command comes here as the command window in red, which means that there's an error in your code line. So if you have an error in your code line, not to worry. It's just for you to come back and check your command line to see where the problem is. It could be a comma, it could be a full stop, it could be a command that is case sensitive. So you just need to check that. Then you work on your code line again, and you can now send that. So the next thing we need to do is label define. So label the values. So we now have two. The first, okay, recode. Why the second one is age, recode one. Then we press enter. Now that is done. Then we can now tap our new variable to see the result. Tar, the new variable. Then we have this. Does that sound good? So we've recoded age, that is continuous variables, to what we have as a categorical variable. I want to believe that that is pretty straightforward. Is one thing that we have done. Now, I don't know the time, at what point you missed me, okay? But this is an example. I'm sure you can see my screen. So what I've just done is to run an histogram to check if height follows a normal distribution. I mean, follows a normal distribution. But from what you can see on your screen, you will observe that this actually follows a uniform distribution and does not follow a normal distribution. All right. There's the question that was asked. I think it was Dr. Deleke that mentioned that there's a way of using a data distribution. Okay. So there are other examples. So if we want to run the statistics, to come to statistics, then we come to summarize. tables test and come to distributional plots, then we can choose. I'm sorry. The interpretation says that Skyropiro wiki test is larger than 0 distribution. Now let's go back to output. Now you can see our output at this point, that our p-value is not greater than 0.05. So histogram, I can do that again. So I'll just pick my code here. That is code 20. All right, if I double click the code line, then it's run automatically. So I I'm so sorry. My is not a read live data set. So the first one I want us to run is chi-square. Now let's say an hypothesis says that there is no significant there is significant relationship between age and determines or is there any association between my age and my level of education, which implies, does it mean that the higher the age, the higher the higher the level of qualification one can attain? Are we together now? So I'm just trying to paint a very rough scenario. Okay, so does it implies that the higher the higher the age, the higher the level of education that an individual can attain? So the hypothesis is there is no significant, or there is, because an hypothesis is an assumption that have the null hypothesis and the alternative hypothesis. So the hypothesis is there is a significant relationship between age and education. So which implies has to be nominal. So in doing that, we tab, then we bring in our age cards, the one we record, Then we bring in education. All right. Then we put a comma. Then the next thing we need to do is to do a calculation. Remember that when we have the formula for a mathematical formula for a chi-square, we have the expected frequency and the observed frequency and all of that. So you can also have your column and your row total. So let's say, for example, now that we want to have our column total, you just use column row in this format. Then you put your chi-square as you want to run, then you press enter. Excuse me. So this gives the result. So you can see that the total is at the row. Now, if you bring this back and you change this to column, you can see, so the total is at the column, but the results in terms of the chi-square value and interpretation differs. So this shows that, for example, about 65% of individuals in tertiary education are between the ages of 14 to 19. Please note that this is not a real life data set. It was just a data set that was generated using a random approach. Out of the 151 individual that falls between the ages of 14 to 19 in the study population, 65% had tertiary education. So this is just the explanation of that. Then if you look at the p-value here shows that there's a significant relationship between age and sex, because the decision rule says that reject H naught if the p-value is less, that is the alpha value, accept if otherwise. Are we together now? The p-value is less or equal to 0.05, accept if otherwise. Now, in this case that present before us, the p-value is 0.004, which is less than 0.05, which implies that the hypothesis is significant and there's a significant relationship between age and education. Now you can see here called DF. So DF of freedom, all right? Degree of freedom. And your degree of freedom is calculated by row minus 1 multiplied by column minus 1, all right? Or you say column minus 1 or bracketed. In this case, our column is 3. So 3 minus 1 equals to 1, 2, 3, 4, 5, 6. Our age is 6. So 6 minus 1 is 5. So 5 multiplied by 2 equals 10. And that is why our degree of freedom that we have there is here, because it's a nominal variable, or what we also call the categorical variable. All right. So the next one we can also do is to do what we call the correlation. All right, correlation. Now the difference between a correlation and a chi-square is, number one, in the scale of measurement. So for chi-square, it follows a nominal scale. Why for correlation, it follows ordinal scale, or also what we call the continuous variable. That is one. Secondly, a chi-square is going to tell you there's an association or relationship between variables, but it won't tell you if the relationship was strong or not. Now, when your coefficient of correlation, R, small r, all right, when your coefficient of correlation R is close to 1, is close to +1, then we say there is a strong relationship. Are we together now? So when your coefficient a coefficient of correlation, R, small capital R, is close to +1, then we say there is a strong relationship. So your relationship could be weak. It's weak when it's not close to 1. And it could be negative when it's, so it could be negatively strong or positively strong, depending on the plus or minus sign that you have in your output. So let's run for H and I, for example. If I'm using my command line, so I'm just going to use CORR, or you use correlate. All right, they are the same thing. It was okay. I'm using height and I'm using weight. What am I using? Are continuous. Are we together now? Because both variables are continuous. Then I'm going to press enter. Now we can see, for example, okay, this is the correlation value, okay, minus 0.043. So this is a negatively strong relationship. I mean, sorry, negatively weak relationship, all right? Negatively weak relationship between height and weight. And if you also look at the p-value, this is the p-value that we have in the dialogue, in the diagonal line, okay, which is 0.1, all right? So 0.1 is not less than 0.05. It means that there's no significant relationship between height and weight, all right? Is that clear? So another test we can run. So those are the possible tests we can run for what's it called, for relationship. Another one we can also run is a regression. All right. So your regression must have a dependent variable and the independent variable. We've all talked about this. Your dependent variable has to be continuous, and your independent variable can also be continuous or can also be categorical. All right. When you have one dependent variable, one independent variable is when we have a linear regression, or what we call the simple regression. But when you have one dependent variable and more than two independent variables, they have a multiple regression. That is when your y equals to beta naught plus beta 1 x1 plus the error term. That's the equation line for a simple regression. But when you have a multiple regression, you have your y, your dependent, equals to beta naught plus beta x1 and beta 1 x1 plus beta 2 x2 dot 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 plus Please, can you hear me now? Hello? Hello?
Yes, we can hear you. We can hear you. Can go ahead.
I'm sorry. So the head stuff I was using, so it ran out of battery and I wasn't aware. So I just plug it and I'm
It's okay, sir.
have an hypothesis intention to disclose variables or based on yeah, for example, we might want to look at location. So location might have the tendency of predicting one's willingness to disclose in the rural area, are not well empowered to disclose their area, are well educated to uh, HIV status, it could be education. Probably people who are well educated are more exposed to disclose. Religion also could also be a determinant factor. Probably your religion does not really want you to use family planning, for example. So these are example variable, all right? So it could be yes or no. What are the predictors of my salary? Salary take home. So your salary in this sense could be a continuous variable. Develop a model that could predict, for example, could be sex, yeah? Could be your experience, length of experience, could be your education. Probably someone who has a PhD might be earning some more than some. Much more than somebody who has a bachelor degree, or somebody who has 12 years experience could be earning much more than somebody who has a 5 years experience. So all of this could be your predictor. So we want to understand what are the predictors of my home take. Is it my age? Is it my Is it my age? Is it my education? Or is it all as it all? So the example we have here, so we want to use disclose. So we just start with regress. Then the first thing you bring in is to bring in your dependent variable. Dependent variable. That is what? Intention to disclose. Then we bring that in. Then the next thing is to bring in our independent variables, the predictors. So age, for example, and what have you. Then we tab it. Another table. So if some of us are familiar with statistics, so this SS is called sum of square. EF is called degree of freedom. Then MS, I think is called means of square, but I can't really remember again. Then we can see this is our degree of freedom. Then this is a number of observation. Then we can see the F statistics. But what is important to us here is the one that has probability greater than F, which is our p-value. So looking at this p-value, we can see that this is not significant. Please note that the data set that we are using for this sample is just a random data. It's not the real life data, it's not a survey data, but just for us to be able to practice, because when we understand this, we can actually work with a real life data set. So we can see from here that the p-value is greater than 0.05, it means that there is no significant relationship between all of these predictors and intention to disclose status. Please note that. Please again, this is just a dummy variable, all right? So this is our R square. So the R square is what we call coefficient of determination, all right? The R square is called the coefficient of determination. So it shows the proportion of the dependent variable. It shows the proportion of the dependent variable that is explained by the predictors. Are we together now? So it shows the proportion of the dependent variable that is explained by the dependent variable. Now, the other one we have here is a coefficient table. Okay, the coefficient table. Now, for each of these coefficient, this actually helps us to be able to build our model. Are we together now? So our beta naught, for example, when we said y equals to, so intention to disclose equals to this our constant, and this is a value for constant. Then I can say location, this value x1, this value x2, this value x3 minus this value h. You understand my point? Now, if it is a econometric, I believe that Dr. What's the name now can relate with me. I can't really remember again. That is when we say one, how is it explained? One increase, I can remember when I say one increase in money supply will lead to an increase in GDP. Can you relate, Dr.? Let me check the name now. Dr. Adedeji. Yeah. So we say that one one increase in GDP or money supply will lead to an increase in GDP when you hold every other variable constant. That is when you're trying to explain it in the econometric term. Now, but however, if you also look closely at each of all of these variables, it's not significant. Education is not significant. Excuse me. Gender is not also significant. So these are ways by which we can run is what we call logistic regression. Okay, logistic regression, which is also called the binary regression. So for your logistic regression, the most important thing about your logistic regression is that your dependent variable means yes or no. All right. So, and for example, our intention to disclose, trying to tap that, we can see it's in binary, and then we can also recode that to be, so one is yes. So I'm just trying to edit the code, and do label, then we type it again. Then we have this, okay? So if we go through to disclose, then again, we can bring in all those, just for example, then that is it. Now the command line. So instead of going that for your logistic regression or your binary regression, why in the case of regression, your key difference between the two statistics. Now you can also see here that the p-value also is not significant. The confidence interval, and this is the p-value. The value here is significant, okay? But we can also explain stuff in terms of the significant, all right? So for example now, age has the highest odd, okay? It has the highest odd here. That's an example relationship between, I don't have data set here, between, okay, between education and height. No, should I say, no, let's say, but any significant difference between education and weight, then we tab it. All right, so we can see the results. We can see the number of observation. We can see the R square. We can see the partial sums of we can see the degree of freedom. Can also see the p value. Okay, so this is coming as weight because this is the factor. Again, we can see that that is not also significant. Another test for difference is in using independent tests. All right, in doing that, you can that's the command line. You can just simply use t-test. Also check around is when you want to use your non parametric test, and you know, you can come to this point, then you just go in the same route. You select Kruskal-Wallis, for example. Note that that is when your data set does not follow a normal distribution. Then your outcome variable, for example, could be weight, sorry. Then your defining variables is sorry about that. So I think at this point, one critical thing that we've been able to achieve in this introductory class, or probably I'll say beginners class, because they are more advanced thing to what statistics can do, is that I want to believe that majority, if not all, now have a better understanding of descriptive and inferential statistics. We now have understanding that there are two levels of research questions that can be developed. Your descriptive, which answers to your research questions, your hypothesis formulation, which could be a relationship or association, or the part that could be differential. All right. Then we also understand scale of measurement as an important measure in determining the type of statistical techniques that we need to use for analysis in terms of the four levels. We also have an understanding in using normality tests in follows if a data set follows a normal distribution or not. So that can help us to determine if we are to use a parametric or a non-parametric test. Then we also have an understanding around variables in terms of dependent, independent variable, discrete variable, continuous variable, extraneous variables, and all of that. Then we also have an understanding on how to use different methodology in testing for normality in terms of graphical method and also numerical method. Then we can also interpret based on the outcomes of all of these tests. Then we also have an understanding of running a chi-square where our data set is nominal or categorical. We have understanding when we are running a correlation, when your data set is continuous or ordinal. Then we also have an understanding of running regression analysis. We also have an understanding of running a logistic regression when your dependent variable is in binary. Then we also have an understanding of running analysis of variance. Then we also have an understanding of running a t-test, if the case might be. Then we also have an understanding of running non-parametric tests if our data set does not follow a normal distribution. And again, we also have the understanding of the status environment. We have the understanding that there are three ways of interacting with STATA: by the command, by do file, or by the menu dialog box. Then we also understand that when we are starting our data set, when we are starting up in the STATA environment, the first thing we need to do is to begin with a log. All right, you begin with a log. When you are done with your log, you at this point you close your log. All right. Then you also understand that you can import into Excel, into STATA environment, and then all of that. Remember the windows that we have. Now, when we have the review windows, all of these review windows, command can be sent into a do file. All we need to do is to select the appropriate command that is of interest to us. You can see the way I'm selecting it. So I press Control down, then I'm pressing each of the command. When that is highlighted, you just right click. You can see send selected to a do file. Okay, when you click this, for example, it takes all of these to the do file. So this is a do file, for example. So any line that you want to execute, just put your cursor on the line. Then you come to this icon icon that is called execute do. Okay, or if you want to run all, just highlight all, then you click here, then it runs automatically. All right, so these are ways by which you can actually do that. So at this note, therefore, it has been a very long talking. I'm sorry about that. I'm going to open up the floor to take questions, to take clarification, even as we end this section. Please note it, number one, the data set we are using is just a dummy data, it's not a real life data set. And this class, as it were, is a beginner's class because I want to believe that it's just like a refresher class to some of us, but there are much more that STATA can do as much as possible. But we need to lay and build a foundation that the intermediate and advanced class, as it were, can be built upon. And why there's a long talk on my part is because there's a long gap from the time we left it and where we're picking it up, just to try to refresh people's memory so that we can, I can bring people up to speed and what have you. So at this point, I'm going to stop and I'll allow Dr. Gbenga to come in to coordinate the questions, the clarification, and the contribution section. Thank you, and over. Dr. Gbenga, please.
Thank you so much, Prof. Yeah, thank you. I'm there, sir.
It seems the network isn't great. We can't.
By the show of grace, and actually verify, we can actually but one thing I'm very sure is that I promise the with us, and then the recording of
We can't hear you.
Dr. Gbenga, your network isn't great. We can hear you. Okay, so you mentioned that, can you ask question? Kindly ask your questions or contribution or, clarifications. I think this, the video is going to be shared and some of the materials probably will be reshared. Anyone you don't have, we just ensure that we share that again so you can go through the audios, the videos, then practice and what have you. Questions, contribution.
Okay, thank you. Thank you for the section so far. It has been a kind of an eye-opener and then for someone to learn more. I just want to add that just like you said, the slides should be shared with us so that we can have something to to practice with, and one can check if there's any there's need to like do that. And then in addition, the certificate, I hope I'm getting a certificate for the training.
Absolutely. Dr. Gbenga confirmed, but I
Okay.
Yeah.
I can hear you. It's okay. So thank you very much. I really appreciate it.
Thank you, Dr. Deji. Please, can we have, sorry. Okay, excellent. Okay, thank you very much. So any other contribution? Let me also mention that I might also be available to probably give some support in terms of maybe if you needed some service. You know that there was a time that Downsy reached out to me, but I couldn't, what have you. But I think then I might not do the analysis for you, but I can guide you that, okay, do this, check this, have you done this, guide you, or probably port with the consultancy in terms of analysis, get work done. Yeah, I hope that's clear. Yeah, so it could be it could be a PhD work, it could be some national survey, it could be baseline study and all of that. So even if it's not something I can hand you due to my schedule, but I think we have other team of experts that we can recommend as much as possible. So on this note, it seems we're not having any other questions or clarification. So we can drop some words at the WhatsApp group, and then Dr. Benga can also help us with some next steps as much as possible. So I think if there's no any other questions or asks, I think we can call it a day and say thank you very much for the opportunity to be part of this. Then Dr. Benga will discuss on necessary next step if there be. Yeah. Then Dr. Benga was telling me that even manuscripts, okay, so we can work on manuscript together as need be. Okay, we can form a team on a manuscript, the analysis, we published it and rely on us. So probably I should allow two people to just close. Thank you, Dr. Ibitoye. So can we hear something from Downsy and then maybe Suleiman? I know Dr. Deji have been talking. So let's say a closing word from Downsy and also from Suleiman Idris Ahmed. Then we'll close from there. A closing remark from Downsy and Suleiman, please.
I think it's been wonderful. I really, really am just grateful for this kind of opportunity because I'm just a student. But all the same, I really am happy because there's something like this, like a mentorship, and I really like it to continue, even if the class ends. It doesn't stop the mentorship process. So I would still like to learn more and know more at the same time. Thank you.
Sulaiman?
Can we hear from